Why AI needs so much data. Season 1, AI Basics, Explained Without Hype. Episode 4. One. Introduction, the data hunger problem. Artificial intelligence has one appetite that never seems to be satisfied. Data. More data. Larger datasets. Constant streams of new information. Every major AI breakthrough is accompanied by the same explanation. The model was trained on more data. This raises an important question. If AI is so advanced, why does it need so much data just to function? Why does it require millions or billions of examples to do things humans can learn from a handful? The answer reveals a fundamental truth about how AI works and why it is powerful, limited, and deeply dependent on the world we create around it. To understand AI, you must understand its dependence on data. 2. Data is not knowledge. One of the biggest misconceptions about AI is the idea that data becomes knowledge. For humans, information can turn into understanding. A person can read a few examples, grasp a concept, and apply it broadly. AI does not work that way. For AI, data is not knowledge. It is raw material. Data is not meaning. It is input. AI systems do not extract understanding from data. They extract patterns. And patterns require scale. The more data an AI sees, the more patterns it can statistically approximate. Without enough data, the system cannot reliably generalize. 3. Why humans need less data than AI. Humans learn differently. A child can see a few pictures of a dog and understand the concept of a dog. They can recognize new dogs they have never seen before. They can understand that a dog is an animal, that it moves, that it interacts with the world. This happens because humans are not learning from scratch. Humans are born with cognitive structures shaped by evolution. We already understand physics at an intuitive level. We already understand objects, movement, causality, and goals. AI does not have this foundation. AI starts with no built-in understanding of the world. Everything it knows must be inferred from data. So instead of understanding concepts, it approximates them statistically. And that approximation improves only with scale. 4. Data as a substitute for understanding. Because AI lacks common sense and lived experience, data becomes a substitute. Where humans rely on intuition and meaning, AI relies on frequency and correlation. If a pattern appears often enough in data, the model treats it as important. If a pattern is rare, the model may ignore it. This is why AI systems struggle with edge cases. Humans can reason about rare situations. AI needs enough examples of those situations to model them. Without data, there is nothing to adjust. No matter how advanced the algorithm, it cannot learn patterns that do not appear in the data. 5. The statistical nature of AI learning. AI models operate in probability space. They estimate likelihoods. Given this input, what output is most likely? Given this history, what outcome is most likely? To estimate probabilities accurately, the system needs many examples. Small datasets produce fragile models. Large datasets produce more stable statistical estimates. This is not intelligence. It is math. The system is not discovering truth. It is reducing uncertainty. And reducing uncertainty requires exposure to many variations of the same pattern. 6. Why language models need billions of words. Language looks simple to humans. We speak fluently. We understand nuance. We grasp meaning instantly. But language is incredibly complex. Words change meaning based on context. Sentences depend on culture. Tone matters. Implication matters. AI does not understand any of this. So it compensates with scale. By seeing billions of words, the model learns statistical regularities. Which words tend to follow others? Which phrases appear in similar contexts? Which structures signal explanation, argument, or narrative? The model does not know what the words mean. It knows how they tend to appear. Without massive data, this imitation would fail. 7. Images, sound, and the same problem. The same logic applies to images, audio, and video. An image is not a concept or an AI. It is a grid of numbers. Each pixel is a value. To learn that certain pixel patterns correspond to objects, the system needs many examples. Lighting changes. Angles change. Backgrounds change. Humans handle this naturally. AI must see enough variations to statistically stabilize its predictions. This is why AI trained on limited image data fails easily when conditions change. More data reduces brittleness. But it never produces true understanding. 8. Data diversity matters more than people think. It is not just the amount of data that matters. It is diversity. If an AI system sees only a narrow slice of the world, its patterns will reflect that slice. This is how bias enters AI systems. Not because the AI is biased, but because the data reflects unequal or incomplete realities. If certain groups are underrepresented, the model learns weaker patterns about them. If certain behaviors dominate the dataset, the model assumes they are normal. Data does not describe the world as it should be. It describes the world as it was recorded. AI inherits those distortions. 9. Why data collection never ends. AI models degrade over time. The world changes. Language evolves. Behavior shifts. Trends fade. New patterns emerge. An AI trained on old data becomes less accurate. So systems must constantly ingest new data. This creates a permanent demand for surveillance, tracking, and monitoring. The hunger for data is not accidental. It is structural. Without fresh data, AI loses relevance. This is one reason modern digital systems are designed to collect continuously. 10. Data as power. Data is not just a technical requirement. It is a source of power. Whoever controls the largest datasets can train the most capable models. This creates asymmetry. Large corporations with global platforms collect enormous amounts of behavioral data. Small players cannot compete. This is not because the algorithms are secret. It is because the data is concentrated. AI performance scales with data access. This is why data ownership becomes a political and economic issue. 11. Why AI fails without data. When AI is deployed in environments where data is sparse or unreliable, it performs poorly. In medicine, rare diseases are harder to model. In law, unusual cases confuse automated systems. In crisis situations, historical data may not apply. Humans can reason in these situations. AI cannot extrapolate without patterns. This is why AI systems often fail precisely where judgment matters most. They perform best in repetitive, high-volume domains. 12. The illusion of objectivity from data. People often say data is objective. But data is collected through human systems. Decisions about what to measure, how to measure it, what to ignore. All of these shape the dataset. AI treats data as ground truth. It does not question the process that produced it. So biases and errors become embedded. The larger the dataset, the more authoritative it appears. But size does not guarantee fairness or truth. It guarantees statistical confidence. 13. Data labels shape reality. In supervised learning, humans label data. These labels define categories. Spam or not spam. Risky or safe. Approved or denied. Once labels exist, the model learns to reproduce them. If labels are flawed, the model reproduces those flaws at scale. AI does not reinterpret labels. It does not challenge them. It enforces them. This is how historical decisions become future defaults. 14. Self-supervised data and hidden assumptions. In self-supervised learning, the system creates its own training signals. This reduces human labeling effort. But it also hides assumptions. The system learns structure based on the patterns present in the data. If the data contains dominant narratives, those dominate. If certain perspectives are missing, they remain missing. The system does not seek balance. It reflects frequency. 15. Data volume versus data quality. More data does not always mean better outcomes. Low-quality data produces noisy models. Biased data produces biased outputs. Duplicated data reinforces certain patterns. But because performance metrics often improve with more data, quantity is prioritized. This leads to massive data accumulation without deep scrutiny. The system improves on benchmarks. But real-world reliability may not improve in the same way. 16. Why I cannot know when data is incomplete. Humans can recognize gaps. We know when we lack information. AI does not. If data is missing, the model still produces output. It fills gaps with statistical guesses. This can be dangerous in high-stakes settings. The system does not pause. It does not ask for clarification. It outputs something. This behavior is not intelligence. It is obligation to the objective function. 17. Data and feedback loops. Once AI systems are deployed, their outputs influence behavior. That behavior becomes new data. The system trains on its own impact. This creates feedback loops. What the system shows influences what people do. What people do reinforces what the system shows. Over time, diversity can collapse. Popular patterns become more popular. Rare patterns disappear. The data narrows. The system becomes more confident. This is not wisdom. It is reinforcement. 18. Why data dependence limits AI. AI cannot reason beyond its data. It cannot imagine fundamentally new concepts. It cannot invent values. It cannot step outside its training distribution. When the world changes abruptly, AI struggles. Humans can reason abstractly. AI must wait for new data. This delay can matter. In crises, novelty is common. AI is weakest where novelty dominates. 19. The myth of data completeness. No dataset captures reality fully. Every dataset is a partial snapshot. AI systems treat snapshots as if they are the world. This creates blind spots. People forget that the model sees only what was recorded. Unmeasured phenomena do not exist to the system. This is why AI should not be treated as a complete representation of reality. It is a compressed shadow of the past. 20. Why this matters. AI needs so much data because it lacks understanding. Data compensates for the absence of meaning. Scale compensates for the absence of intuition. Optimization compensates for the absence of judgment. This makes AI powerful. It also makes it fragile. The more we rely on AI, the more we rely on the data pipelines behind it. And those pipelines reflect human choices, incentives, and inequalities. 21. Core takeaway. AI is not learning the world. It is fitting the world into statistical patterns. The more data it has, the better it fits. But fitting is not understanding. And when systems that do not understand are trusted to make decisions, the consequences matter. If this episode helped you understand why AI depends so heavily on data, like this video so more people can see it. Share it with someone who believes more data automatically means better intelligence. And subscribe to Uncovering Facts for clear, hype-free explanations of technology and power. Next episode, the one thing AI can never do.